Hello and welcome to my channel. My name is Jack, and today I'm going to show you some tips on resource tuning in OpenShift. Hope you enjoy this video. Today we're going to start with a demo of a real-life issue. And now let's dive in. Okay, here's my admin console. Get into my project, navigate to the deployment configs. We're going to look into one of the deployment config here. As you can see, there's no pod running under this config right now. So I'm going to start one. I'm going to switch to the pods tab. You can see that container is creating. I'm going to get into the pod itself and switch to logs tab so I can stay on top of stuff. Let's give it a few seconds to start. Oops, looks like something just happened. Obviously, an error just occurred while executing one of the post start command. If we slide to the right, we can see the pod has been killed. We slide down in the log section, we can see it says finishing, exiting. So what could be the problem? We have been running this pod locally for a while, and nothing like this happened before. Before we answer the question, we need to look into some basics of resource tuning in OpenShift. Let's get started.
Let's start with some important metrics in OpenShift. The first one we're going to talk about is CPU. The most common unit used to measure CPU usage in OpenShift is called a minicore, or M. This is somewhat confusing for beginners. So what is a minicore? A minicore could be considered as a slice of CPU which represents a thousandth of a CPU core. Then what is a CPU core in OpenShift? Let's take a look at the Kubernetes definition. One CPU in Kubernetes is equivalent to one virtual CPU core for cloud providers and one hyperthread on bare metal Intel processors. For example, if your Kubernetes node is on a VM and the VM has two virtual cores, you've got 2,000 mini-cores on your node. Another thing I want to mention about CPU is CPU resource could be throttled. Again, you might be asking, what does that mean? Well, that means your pod could not be able to go beyond the CPU limit that has been assigned to it.
Next, let's talk about memory. Memory is measured in the same way in OpenShift as in regular infrastructure. That means it's measured in bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, or exabytes, just like in the rest of the world. One important thing I'd like to mention about memory is that it's incompressible resource, so it could not be throttled. That means if memory usage of your pod goes beyond the limit, it goes beyond. So what happens after that? Well, your pod gets evicted from the node. In other words, your pod would be killed. And that's exactly what happened in our demo earlier. We'll talk about that in more detail later in this session. Now that we reviewed some metrics, let's take a look at two important concepts, which are requests and limits. First, let's take a look at requests. Requests a guaranteed amount of resource allocated to a container. It should be set to the minimum amount that your application needs to run. Now let's take a look at limits. Limits are reasonable burst of amount of resource that your container is allowed to use. The difference is, limits are not guaranteed, which means if there's no resource left on the cluster node your application is on, you're not getting any additional resources. Another hot topic is about the limits requests ratio. It really depends on the nature of your application and your understanding about it. The more you know about your application, the better you can do with the ratio. A general guideline is to keep requests low and the limits reasonably higher. That way your application won't hog all the resources and allow other applications sufficient resources to run on the same cluster. Generally, a ratio from 1.5 to 1 to 3 to 1 would be considered reasonable. If you want to go higher than that, you should probably consider horizontal scaling. Let's check another important concept, limit ranges. According to Kubernetes documentation, Within a namespace, a pod or container can consume as much CPU and memory as defined by the namespace resource quota. Isn't that just like local? Why did our pod get evicted earlier? That's where a limit range comes into play. A limit range is a policy to constrain resource allocation in a namespace. It could provide several constraints. Here we want to focus on one of them, which is set default request limit for computer resources in a namespace and automatically inject them into containers at runtime. That means if you did not specify request limits for your pod, the default value from limit ranges will apply.
Alright, now we review the basics of resource tuning in OpenShift. Let's get back to the previous problem. Let's first look at the resource quota in our namespace. Let's go to resource quotas, compute long-running quota. As you can see, we only used 11% of memory requests and 22% of memory limit. If we scroll down to the details, that's just about 2 GB out of 16 GB for memory requests and 7 GB out of 32 GB for memory limits. That's far from hitting the ceiling. Now let's go to the limit ranges. We can see that there is a default limits which is set up by our cluster administrator. We scroll down to the bottom.
Those are the values that apply to our pods, as we did not specify any in our manifest. Obviously, the amount of memory is not enough for the application and cause the pod to crash. Next, we're going to fix this. I'm going to pull up a command prompt and run the OC patch command. Now let's go back to the console and see what happens. Looks like it's recreating the pod. And now the new pod is up and running. Here we go. We fixed the issue. If you're not familiar with the OC patch command, you can always go to the YAML tab and get to the resource section and modify it directly from here.
Alright folks, that's it for today. If you like this video, make sure to hit the subscribe button and turn your notification on so you never miss a video from Learn Tech with Jack.